This diagram shows the general structure of the Thunderbox module and its environment. The Thunderbox module itself in the center consists of a single printed circuit board with a communication interface, a three-phase motor controller connected to a three-phase inverter, and a heat spreader and mounting plate. Around the module are the user systems, including a three-phase brushless motor with velocity and position feedback, an external emergency stop system, an external communication interface, and a user PC for configuration. In order to drive a motor, the Thunderbox includes a high-performance three-phase inverter constructed from MOSFETs. This inverter switches current into the three-phase motor that's shown, and also senses the current that is being driven into the motor for control. The three-phase inverter is controlled by a three-phase motor controller. This motor controller is centered around a motion control processor from Performance Motion Devices. It generates PWM signals to control the inverter bridge, and also receives feedback in terms of motor current from the inverter, and also through motor sensors such as a quadrature encoder and Hall phase position sensors. The motor controller is also responsible for low-level commutation, that is, to make the motor spin by changing current directions, which it does sinusoidally, and also to control parameters of motion such as the torque of the motor and its velocity. The Thunderbox also includes a combined heat spreader and mounting plate machined from a single piece of aluminum. This part allows for removal of heat from the three-phase inverter generated while driving the motor, and also provides an easy mounting point to the user's robot. The Thunderbox communication interface coordinates communication between the user systems via RS-232 or SPI, and the rest of the Thunderbox systems such as the three-phase controller and onboard sensors. To protect both the Thunderbox and the user system, the communication interface coordinates emergency stop communication between the Thunderbox and an external system. The external emergency stop bus is notified of internal faults on the Thunderbox, and the Thunderbox may also read in external faults and shut itself down to protect itself. The Thunderbox package also includes a PyQt-based configuration GUI. This program allows users to plug into the Thunderbox via the communication interface and reconfigure parameters of the Thunderbox, such as motor loop constants and the number of encoder counts per revolution. Under normal operation, communication interface would receive commands over SPI from an external user board, such as Dynamic Robotics Laboratories Medulla. Motor commands, as well as setup and feedback data, will be transferred back and forth between these two systems via the SPI link.